Okay, in this video we're going to plot numbers on a number line and we're going to solve inequalities. So the first thing I'm going to do is plot numbers on a number line. For the basis of our study, we are going to look at three different types of numbers. We're going to look at natural numbers, we're going to look at integers, and we're going to look at real numbers. Starting off with natural numbers. Natural numbers are denoted by this sign n for natural numbers. And a natural number is any positive whole number. So 1, 2, 3, 4, all the way up to infinity are the natural numbers. Next we have integers, denoted by a z for some reason. And integers are any whole number, positive or negative. So we could have a -2, -1, a 0, a 1, a 2, a 3, all the way up this way and all the way back that way. And lastly then we have real numbers. And for the purposes of our study, I'm going to say it's any number. That's not technically right, because there is other numbers like imaginary numbers, okay? But for the purposes of our study, let's just say it's any number. And what I mean by any number is it can be positive, negative, whole, part, fraction, decimal, it can be rational, it can be irrational, so any number you can think of. So this would be a real number, this would be a real number, pi is a real number, 2 is a real number, any number you can think of. Okay, so if I was to show these on number lines, well, let's look at the natural numbers first. So if I was to show the natural numbers on a number line, so let's say this is 1, that's 0, 2, 3, 4, 5. So if I was to show these natural numbers, well, I wouldn't have, well, I put in some minus numbers as well, sorry. Okay, now if I was to show these natural numbers, I would say, well, natural number, it's not 3, so I'm not going to highlight the 3. Sorry, it's not -3, so I'm not going to highlight the -3. It's not -2, it's not -1, it's not 0. It is 1, so I can highlight 1, I can highlight 2, I can highlight 3, 4, 5, and so on up this way. Notice I didn't highlight 1.5 because it's not 1.5, okay, because natural numbers are only whole numbers. So it's dots I'll be using to show that. Integers then. Again, we have the 0, 1, 2, 3, 4, 5, -1, -2, -3, etc. The integers now are any positive or negative whole number, so I can highlight my -3, -2, -1, 0, 2, 3, 4, 5, and again I can show that they keep going down the way, -4, -5, and they keep going up the way, 5, 6, 7, 8. Okay. Lastly then, my real numbers. So my real numbers, again, my number line, 0, 1, 2, 3, 4, 5, -1, -2, -3. Now, this time, well, real number can be -3, can be -2, could also be -2.5, -2.25. So am I going to continue putting these little dots for every single number I can think of? Okay, like so. This will take me a while. The best thing I can do is I can shade in all the number line, because remember, real numbers are any number I can think of. So all the numbers between -3 and 5 are real numbers, so I'm going to shade in all of them, and again it goes all the way up and all the way down. Okay, next we're going on to inequalities. Inequalities they're almost the same as an equation. Okay, for the most part we can treat this greater than or equal to sign, or greater than or less than sign, whatever, as an equal sign. Okay, for the most part. Let's just start off with what I have written in green here, just to make sure, or recap on what I hope you know. So, first of all, it says 3 equals 3. Okay, this will say, if I put a line through it, 3 does not equal 2. This here, this means 3 is greater than 2. Now why is that? As you can see, I've drawn a little It looks more like a fish than a crocodile, but it is meant to be a crocodile. And if you remember in primary school, the crocodile mouth will always face to what's bigger. Yeah? So in here, the crocodile is going facing towards the 4 as opposed to the 2. Okay? So likewise with this here. The mouth will face to what's bigger. So 3 is bigger than 2. On the next one, 3 is less than 4. Now, if you can see this one, there's a line underneath that crocodile. See in red there? That means 3 is 3 is less than or equal to 4. And the next one, 3 is greater than or equal to 2. Okay? Right, so let's look at this sum to the left now, and we'll solve it. Now, as I said already, for the most part, we can treat this greater than or equal to sign as an equals. Okay? So I'm just going to write it down. So treat that, or that, or that, or that as equals sign, except when changing the signs across the inequality. Okay, and I'll prove that now. Alright, so let's take this. Okay, let's go 3 plus 4 equals 7.